Okay guys, so this is video 3. We're going to look at hydrocarbons. Once again, we just got done looking at binary molecular compounds, so binary covalent, two nonmetals. So hydrocarbons are a special class of binary molecular compounds. They are strictly made of only carbon and hydrogen, hence the name hydrocarbon. Okay, hydrocarbons are a very important source of fuel. Okay, you deal with it, especially if you drive. We will study two general types of hydrocarbons, straight chain and cyclic. Okay, so straight chain, the prefix that we are going to look at indicates the number of carbons in the molecule. You're going to have the suffix ane at the end, which means that the carbon atoms are arranged in a long chain. And so if you look down here at all these names, you have methane, ethane, propane, butane, pentane, all that stuff. It means that it's a straight chain hydrocarbon. We'll go through the different formulas here. I do want to have you highlight this section here. It says, note that these compounds follow the general formula CX H2X plus 2. Okay, so what this means is that the prefix that you come across, whether it's 1, 2, 3, 4, or 5, is going to determine how many hydrogens are in your formula. All of the alkanes above are going to follow this pattern. Okay, so let's look at our prefixes. So for 1 carbon, the prefix is meth, 2 carbons is eth, 3 prop, 4 bute. Okay, those 4 are different from your binary molecular compound prefixes that we just learned. Okay, but the rest of these should match up. Pent, hex, hept, oct, non, dec. Okay, for 5, 6, 7, 8, 9, 10. Now let's look at the pattern real quick. So CX, okay, whatever your prefix is. So for example, prop means 3. You would plug in the 3 for X, and then plug in the 3 for X here as well. So 2 times 3 is 6, plus 2 more is 8, and that's how we get the propane formula, C3H8. That same pattern applies to all of these. Okay, decane, 10 carbons, okay? So 2 times 10 is 20, plus 2 is 22. And so you can do that same pattern for all of these. So what you need to study mainly right now is the prefixes meth, eth, prop, bute, pent, hex, hept, and know when to apply those to hydrocarbons. Okay, so let's go down to cyclics. Cyclics simply add the prefix cyclo in front of the name. Okay, and it indicates that the carbon atoms are arranged in a circle. 1 or 2 carbon atoms cannot be arranged in a circle, and so if you look at your prefixes, you're going to start at prop, which is the prefix 3. Okay, before we go into these, I want you to note that all of these compounds follow the general formula CX2X. So cyclopropane. Okay, and we'll learn about how to draw these a little bit later, but basically you have 3 carbon atoms, okay, in a circle, all bonded together. Once again, we haven't talked about Lewis dot structures yet, so don't focus so much on the drawing. 6 hydrogens, okay, and so each one of these would have a hydrogen attached to it. Now, on your worksheet, you may see something like this, CH2, 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 and all bonded. That would be cyclopropane, okay? Let me erase this real quick and kind of show you what a straight chain would look like for just propane in general. Okay, so if you look above and you look at propane C3H8, it means that all of our carbon atoms are bonded together and that you have 8 hydrogen bonds surrounded around those. And so this is what a straight chain would look like versus a cyclic. Okay, so that straight chain, this is cyclic, and this would be propane, cyclopropane. Okay, so for right now, what you need to focus on your worksheets is anytime you see carbon and hydrogen, is figuring which one of these patterns it falls into.